Okay, so today we're discussing differentiation and the power rule for IGCSE mathematics. So what is differentiation? Differentiation is what we use when we have a function and we want to find its gradient. And the gradient essentially means the rate of change. So I'll show this on a graph in a bit, but the notation that we use is if I have a function y equals f of x, then the differentiated function would be dy by dx if it's in the form y equals something, or if it's in the form f of x equals something, I can also use f prime of x, and they're both equivalent, they're just different notations. Let's use an example. So if I have a curve here on a graph and it's just y equals f of x, and I don't exactly know what the function is, but this is how it looks. If I want to find the gradient, say at this point, I'll name p. One way I could do it is literally take a line and draw it at a tangent. That means that this angle and this angle are exactly equivalent. And then I could use rise over run as a straight line graph and find the gradient. But that's only an estimate, it's not an exact point. So what I can do is I can differentiate this function and then input the x coordinate of the point. So we'll do that in an example. But the general rule for using the power rule is that if I have a function y equals x to the n, then dy by dx is multiplied by the power, so you get nx, and then you reduce the power by 1, n minus 1. So let's use an example. Say y equals 5x cubed. Then dy by dx would be, I multiply by the power, so 5 times 3, I multiply the coefficient by the power, so I get 15, right, x, and then you reduce the power by 1 squared, so that's dy by dx. So I could put in any x coordinate into this function and get the gradient of that line at that point. So let's do a few examples. What is the derivative of y equals 5 to the x cubed, as we did there, and then 1 over x to the 6th? So first thing is that we can't have any fractions. We should always rewrite it as a power of x. So then let's rewrite this as y equals 5x cubed, that's all fine there, plus, and using our power rules, we know that this is x to the minus 6. It's a reciprocal if you put a minus there. So now this is the function that I want to differentiate. There's no fractions. So what I can do is write dy by dx. Make sure you always write this to show the examiner that you're differentiating it here. Then multiply by the power. We've just done this, 15x squared, reduce the power by 1. Do each one individually, then plus. Then I'll put this in a bracket, multiply by the power, minus 6x, and then reduce the power by 1, minus 7. And then I'm just going to clean up a little bit, 15x squared minus 6x to the minus 7. And if we check our answer, it's correct. Move on to the second question. What's the derivative of minus 17x to the 16? This is quite simple. So I'll write y equals minus 17x to the 16. Then I'll write dy by dx. And just note here that I could also have written f of x equals, and then I could also write f prime of x equals, they're the same thing. So then when I'm differentiating, I'll multiply by the power, minus 17 times 16, I've just written it here for my reference, so minus 272, and then reduce the power by 1 to get 15. Check the answer, it's correct. Let's do a final example. Y equals 4 over x plus 4 over x squared. We don't like fractions, so let's rewrite this using our power rules. Know that if it's 1 over, then I write the minus 1, plus, same thing here, it's 1 over, so I write negative, so 4x to the minus 2. Then I can differentiate it, dy by dx equals multiply by the power, minus 4, reduce the power by 1, to the power of minus 2. Now here, multiply by the power, minus 8, and then reduce the power by 1. So this is the correct answer, but you can also write it in fraction form here. This is fine too, you can leave it like this. Alright, so the final thing we'll talk about is turning point. So let's say, going back to this graph, I have two turning points here. To simplify this situation, I'll just take a quadratic. So this is my quadratic, y equals f of x, where one of the terms is x squared, and I don't know what the function is, but for example, if I want to find the turning point, this is it. Now, if I want to find the x coordinate of that turning point, what do I know? Well, I know that the gradient here is 0, so I can do dy by dx equals 0, because I know that the gradient is 0, and then once I differentiate it, then set that equal to 0, I can find x. Now just going back to this graph here, and the final thing that we need to know is something called an inflection point here. Now, it just happens to be in the origin for this graph, but it's not necessarily always the origin. The definition of the inflection point is where the concavity of the graph changes. Here we can see that it's concave down because it's pointing down. So this is what we call concave down. And the concavity of this graph is up. So this is concave up. And what we can actually do is we can double differentiate the function, what's called f double prime of x. And if that is positive, so if it's greater than 0, then we know that it's a concave up graph. So this is concave up. And on the other hand, if we double differentiate it and we get f double prime of x is a negative number, so it's less than 0, then we know that it's a concave down graph. And to double differentiate something, you literally take its dy by dx and then you differentiate that again. So in this case, if this was, for example, put in red, so if this is f of x, this is f prime of x. To calculate f double prime of x, I use the same rule, multiply by the power, 30, reduce the power by 1, 2 minus 1 is 1, so then to the power of 1, it's the same thing. So then the double differentiated function is 30x. Alright, now let's move on to an exam question. This is from IB, but this is a similar sort of question as you might get. It's a difficult version of a question that you might get in GCSE. So the first thing is, let's read out the question. Let f of x be x cubed minus 2x squared plus ax, where a is a constant, plus 6. We're told that the graph of x crosses the y-axis at this point, right? And the line L is tangent to the graph at that point. Let's forget that information for now. We'll begin with question 8. We know that when at the y-axis, the x-coordinate is 0. So we can simply input the x-coordinate into this function and find the coordinates of p. So let's do that. F of 0 is, well, 0 cubed is 0. Well, anything to times 0 is 0, so let's just put minus 0. And ax, well, anything times 0 again is 0, so that's plus 0, and then plus 6. So now we know that's equal to 6. And so from that, we're able to deduce that the coordinates of the point P are 0, because it's on the y-axis, 6. Alright, now let's go on to part B. It's asking us to find the differentiated function. That's dy by dx of this function. F prime of x is equal to multiply by the power and reduce the power by 1. So 3x squared minus 4x plus a. Constant here, 6, disappears because there is no x term. And then hence, find the equation of L in terms of a. So we know that this, what we just found, is the gradient of this graph at any point. And what we can simply do is just input the x-coordinate. This is m at any point. And what we can then do is input the x-coordinate to find the gradient at that exact point. So let's do that. F prime of 0, because we know that the x-coordinate of the point P is 0. Well, then that's just 0 minus 0 plus a. So then we know that the gradient at the point 0 is a. And we know the equation of a straight line is y equals mx plus c. But we already know the gradient as a, so let's replace that with a. And then we can use the coordinates of the point and input them into this equation. 6 equals a times 0 is 0 plus c. Final equation, they're asking for in terms of L. So we can then just say L equals ax plus 6. All right. The final part of this question is C. Find the value of a. All right, so it says that the graph of x has a local minimum at q, and the fact that the line L passes through that function. We know that p and q are both intercepts of the line L and the function f, so we can just set them equivalent to one another. X cubed minus 2x squared plus ax plus 6. This is the exact equation that was just given to us for f, and then we'll set that equal to L, which is what we just found, ax plus 6. These cancel, and so now we know that x minus 2x squared equals 0. And we can factorize that, take the x squared out, x minus 2 equals 0. And so if we use the null factor theorem, anything multiplied by 0 has to be equal to 0. So the first thing we can do is set this one equal to 0 and say x squared equals 0, which means x equals 0. Well, we know that because that's one of the intercepts. We know that. Then what we can do is also set this equal to 0, and then say x minus 2 equals 0, which means x 2. Okay, so we found the x coordinate of the second intercept. One was 0, which was p, and the second is q, which is 2. That's the x-intercept. Well, we're asked to find the value of a, but we're also told that the minimum is at point q, and the minimum is simply a turning point. So we know here that f prime of x equals 0. Well, we've already found f prime of x, so let's just take that. Okay, so then we can simply input x equals 2, so f prime of 2 equals 3 squared minus 4 times 2 plus 8. And make sure to set this equal to 0 because we want to find the turning point. So then that equals 12 minus 8 plus a equals 0. And with some rearranging, we can get a is equal to minus 4.